Finding nature of root from a graph. Here are tips to use when finding the nature of a root. To find the nature of the root, you will need to move the graph up or down to cut the x-axis at specific points depending on the question. Examples include, number 1, when I ask for two positive or negative roots, use the y-intercept and turning point values to create an inequality. Number 2, when I ask for equal or one root, use the turning point values and equate the variable. And then number 3, when I ask for no real roots, use the turning point value and make an inequality. Example 1. Use the graph to determine the values of k for which the equation negative a half x squared plus 2x minus 5 is equal to k will have real and unequal roots. In the video below, you'll notice that the k was taken over, so it became negative k. This will affect the graph by making it move up or down. In the following example, you will notice that I want to move this graph to the top. Because if I move it to the top, it will give me my root, which is basically the graph cutting the x-axis. You would notice just as I get to negative 4, which is a little bit too high, I got my two roots. So basically from negative 3, it gives me my two real unequal roots. So you'll notice that k is less than negative 3. So although it went up, you thinking that k should be greater than negative 3, please remember that because of the negative k, meaning the sign changes, change the inequality sign as well. Example 2. For which values of r will the roots of x squared minus 4x plus r be non-real? Currently it cuts two places at the x-axis, so it has two roots. We need to move this graph up in such a way that it cuts nowhere on the x-axis, thus not giving us any roots. So notice as the r value increases, it moves up. When the r value gets to 4, it touches the x-axis once, so we need to go a little bit higher than 4. That is why r is greater than 4. Example 3. Determine the values of k such that negative a half x squared minus x plus 4 is equal to k will have no real roots. Again, you have to take the k over for it to take effect in the graph. Currently, my graph has two roots. So again, I need to move it. In this case, I'm going to move it down. So looking at the video, you notice I'll start moving it up. No, then I move it down by increasing the k value. Once my k gets to 4,5 and then a little bit higher, you'll notice it comes to no real roots. So again, looking at the final answer, it says k greater than 4,5. I know I moved down, so logically you will think less than, but because the k was taken over and the sign changed, you have to also flip the inequality. Number 4. For which values of k will a half x squared minus 2x minus 6 minus k equals 0 have two positive roots? Currently it has one positive root and one negative root. Cutting at x is equal to 6, x is equal to negative 2. So again, I have to do something with the k values to get it to a positive root. That's where the y-intercept also takes an effect. So now, looking at the video again, you will notice I start moving down, but then I move up, 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 and again, looking at it, k is now negative 6, giving me positive roots, up until k equaling to negative 8. So it needs to be in between the two, between negative 6 and negative 8. So you will notice that k needs to be greater than negative 8, but less than negative 6. Example 5. For which values of k will negative x squared plus 2x equals k plus 3 have two unequal positive real roots? Currently I took over the k and the negative 3. Negative 3 already affected the graph. As you can see, originally there is no roots because the graph is not cutting the x-axis. In the video, you'll notice me moving again the graph. As the k value decreases, you will notice the graph goes up. When it gets to about -2, it gets me to my 2 positive roots, but if it goes too high, it will give me 1 negative root and 1 positive root. That is why k needs to be less than -2 but greater than -3. Example 6. For which values of t will f of x equal x squared plus 2x minus 3? So taking that equation, plus t equals 0 have equal roots. To get equal roots or one root, you need to get that turning point on the x-axis. So you will notice again in the video me moving up the graph so the t value increases all the way to 4. So when my t value is equal to 4, it will give me my one or my equal roots. And that is the end of finding nature of roots from a graph.